In this video, we're going to talk about solutions. We've talked about solutions before, and I'm sure that you've used the term, but we need to better understand some of the things that we've discussed. When we're talking about a solution is a homogeneous mixture of two or more compounds. The word homogeneous is probably familiar to you. If not, think about the beginning of the word homo. That means same. So what homogeneous means in terms of a solution is that it looks the same throughout. In chemistry, that means that it's mixed at a molecular level. There are also parts of the solution. The first part is called the solvent, the compound that is the majority of the solution, or the compound that is actually doing the dissolving. There is also a solute, the compound that there is less of in a solution, so the minority, or what was dissolved in the solution. And we need to understand that there can be more than one solute in a solution, so there can be more than one thing dissolved in the solution. But there can only be one solvent. Some examples of some different solutions that you might be familiar with. A solid dissolved in a liquid. That would be something like salt water. There are also solutions of liquids. So a liquid dissolved in a liquid, one that you might be familiar with, is rubbing alcohol, which is isopropanol and water. There are also solutions of gas dissolved in a liquid. You are probably very familiar with these. An unopened Diet Dr. Pepper, which is my favorite, or any other soda that you might like. When you open the can and you hear the little psht from the release of the pressure, that's the gas coming out of solution. You can also have a gas dissolved in a gas. An example of that is air. So there's one majority component of air, which is nitrogen, and all of the other components of air are dissolved in it. You can also have a solid dissolved in a solid, and we've talked about this when we talked about metals with alloys. One thing that's particular to solutions is something called concentration. We need to be able to tell how much of a compound is dissolved in a solution. And in order to do that, we use a term called molarity. We abbreviate it with a capital M, and that tells us the moles of solute per liter of solution. There's an equation for this. M, or molarity, is equal to the moles of solute divided by the liters of solution. And in equations, we can use square brackets to represent the concentration of a substance, or the molarity. So in this case, the concentration of ammonia is equal to 0.100 moles per liter. That capital M is moles per liter. We also say 0.100 molar. Now we need to look at how to use molarity in calculations.